Hello, everyone. We are going to look at your IMFs in solids. I want to go through number 1 through number 5 with you. So if you would get that paper out, the worksheet is asking you to find or indicate the strongest IMF holding together crystals. So you'll see that the London forces, the dipole-dipole attractions, and hydrogen bonds, so those intermolecular forces, those would be accounting for a molecular solid or a molecular crystal. Then we could say a metallic bond, so an intramolecular force. If we have an ionic crystal, we know that'll be an ionic bond. And we know that those network solids, those network covalent solids, are those specific 7 or 8. That 8 one I still can't remember, but I'll remember eventually. But if you see one of those 7 that I want you to memorize, then you know that that's just going to be your network covalent solid. So let's look at NH3. So for NH3, we know that nitrogen is a nonmetal. We know that hydrogen is also a nonmetal. So I have a nonmetal and a nonmetal. So immediately that should indicate we have some type of covalent compound or molecular compound. This isn't one of the network solids that I had you memorize, so that means that it must be a molecular solid. Guys, another easy way to know as well, usually covalent network solids don't have carbon and nitrogen bonded, or carbon and oxygen bonded, or carbon and fluorine bonded with them. For the most part, if we see anything that has an NH bond, anything that usually has a CH bond, anything that has a CO bond, usually those indicate molecular solids. Okay, so we have 2 nonmetals. We have hydrogen and we have nitrogen. So this would indicate molecular. Now I have to determine, is it London forces? Is it dipole-dipole attractions? Or are they hydrogen bonds? Well, if I draw another NH3 molecule, and actually let's do it where I'd have an H here, and H, we'll have that other H coming off of the page, sorry guys. So I could have a hydrogen bond here, hydrogen bond here. So I know that this is hydrogen bonding because hydrogen can hydrogen bond with nitrogen, oxygen, or fluorine. So remember, it is a type of dipole-dipole attraction, but because it's specifically hydrogen with nitrogen, it has to be hydrogen bonding. So the correct answer that you should mark on your page is hydrogen bonds. Okay, let's look at the next one. On number 2, let's say that we just have a sample of krypton, and all of those krypton atoms are going to be neutral. So if I have all of my krypton atoms and they don't have charges, they're not even in a compound, it can't be connected by covalent bonds, can't be an ionic bond because we don't have a metal and a nonmetal, it can't be a metallic bond because krypton isn't even a metal. So immediately I'm going to go to some type of molecular solid, and if I just have krypton, then I can't induce, or I'm not going to have some type of dipole-dipole because I don't have partial charges that are already created through permanent dipoles. There's no hydrogen present here, so we can't have hydrogen bonding. So that means that the only last option is going to be London forces. So remember, in this one, that's where we're going to get that instantaneous temporary dipole, and that's going to induce a dipole. So maybe this one here will get a temporary instantaneous dipole, and it will induce the dipole on this krypton atom. Remember, making it more polarizable. Let's use that vocab of AP chemistry, and thus creating London dispersion forces. So number 2 should be London dispersion. Okay, if we look at the next one, we have HCl.
I know, I was, you know, kind of 45 degrees right now.
Okay, so let's think about these in terms of metals and non-metals. It's the first thing I think we should just always ask ourselves, because that should get us to the right place each time. We know that hydrogen is a nonmetal, chlorine is also a nonmetal, so two nonmetals should leave me with some type of molecular compound. It's not one of my network solids, so which one would this be? Well, I have hydrogen versus chlorine. Chlorine, way more electronegative than hydrogen ever would be. So, because of that, we're going to have hydrogen as a partial positive charge, chlorine as a partial negative charge. So I've created some type of permanent dipole here. So this would be a polar covalent molecular compound. So remember that hydrogen can only hydrogen bond if it's with nitrogen, oxygen, or fluorine. We know that this is simply with hydrogen can only bond with it when it's with oxygen, nitrogen, or fluorine. This is with chlorine, so it's not going to hydrogen bond. So in this one, I would say the strongest intermolecular force would be dipole-dipole. Okay, let's look at F2. That's number 4. Any diatomic, we've talked about this before, is going to be those London dispersion forces. Why? Because in fluorine, we know that the electronegativity here is nonpolar because they have the same electronegativity difference, so that makes their electronegativity difference 0. So they're a nonpolar covalent compound. So I can't have dipole-dipole attractions because that's with a permanent dipole. And I can't have hydrogen bonds because hydrogen isn't even present here. Now, remember what will happen if this comes in contact with another F2 molecule is that I'm going to get one of these where the electrons are going to fall more on one side, creating that instantaneous temporary dipole, inducing the dipole on the other one because we're making it more polarizable. You hear me repeating that several times because that's probably going to be on your test very frequently. Okay, let's look at number 5. Number 5, last one, KMnO4. So we have potassium permanganate. Boom, polyatomic. You should know immediately that if I see a polyatomic present, it is going to definitely be what? An ionic bond. And we know ionic bonds are all about Coulombic attraction. Okay, so hopefully doing the first 5 helps out. I would like you to do the remaining of them. Yes, that means the front and the back. I will post your answer key online for this probably tonight, so that way you try it first before you just look at the answer key. I will post also some multiple choice practice questions and some short answer practice questions for your test, which will be on Friday. I hope you are staying home and staying warm, and I will hopefully see you for a 2-hour delay tomorrow. Bye.